Hi, everybody. I'm back and we're going to learn about Archimedes and the king. So let's sing a little bit to warm up with our pirate song. Ready? Here's the story. Can you see it? Here's the big ship. Here's the boat with the mast right here and the beautiful sail. And they're in the crow's nest. That's a fun hiding place, don't you think? It's this little part here, and they can see from way up high if they can see land. Here's the land. Are you ready? I sailed with you to Timbuktu the day I went to sea. I lived on board a pirate ship and the captain said to me, oh, we go this way, that way, port side, starboard over the deep blue sea. This way, that way, port side, starboard over the deep blue sea. All right, well, let's meet our friends. We have the king. And the king has a very big problem. He needs a new crown. He wants a crown of gold. He has to have a gold crown, of course, because he's a king. But he heard that they sometimes put silver in it instead of gold. It's not what he wanted. It didn't weigh the same, and it wasn't as valuable. It did cost more money, gold and silver. And he wanted a full gold crown, and he was willing to pay a lot for it. But he didn't know if he would get it, because once they mix the silver and the gold, you can't tell anymore if it's got silver in it. The silver doesn't show. So he called his wise friend Archimedes, and he said, Archimedes, I don't know what to do. How am I going to know if they put silver mixed in with the gold when they make my crown? I don't want to pay for gold and just get mostly silver. Archimedes says, I will think about that very hard and I'll get back to you. So Archimedes was very serious about that. So he went to home and he went to take a big bath. He loved his bath. Can you see the water there? And I'm not going to put him in the water, but I want you to imagine that he goes in the water and he realizes that when he sits in the water goes up. And he said, that's very interesting. I wonder how much it goes up. So I'm going to show you with another thing so you can see. Can you see this jar? This jar has some toy in it. So when the toy is in it, the water goes all the way up to here, to the 8. When I take it out, the water is going to go below the 8 because the water moved up once I put the toy in. See, now it's below the 8. Before it was above the 8 or on it. So what happened is when Archimedes went in the bathtub, he realized that his volume, how much space he took up, was the same as how much water went up higher. So if you took all the water that went up this much, right, and you put it in another glass, you would see that that much water was how much he weighed, his volume. So when I take this out again, you can see that when it's not there, the water is below 8. So the word that we learned for this is displace. Archimedes realized that when he jumped in the bathtub water that went up was displaced this much. So this much water all the way around is how much he actually took up. So when the silver was inside the crown that this man was going to make for him, if they were going to, so the story goes that the king found somebody who would make him a crown. And the person, he didn't know very well, and the person wasn't doing the right thing. And he was putting silver in the crown. He wasn't supposed to, like we said. When he put the silver in, guess what? It took up more room, and so it pushed more water out. Because silver doesn't weigh as much as gold, so you have to put more silver in to make it filled up and look like it's made out of gold. So what happened? More water got pushed up. So what happens then? The king knew that he was cheating him. He wasn't doing it right. He put silver in there, and they'd go higher in the water when he put the crown in the water. Just like here, more water was displaced. It went up higher when the silver was in than when just gold was in. So he said to the man, "You're fired. I'm going to get a new person to make me a beautiful gold crown who just uses gold." Well, Archimedes was paid royally for his beautiful, smart ideas and thinking. And Archimedes went on to discover how all kinds of things worked. And I could tell you about those later, but one of them is the measurement of pi, which is a very special measurement of the center of a circle. So that's something nobody else has changed in 2,000 years. He discovered all these things so long ago, which is so amazing, isn't it? So some ideas are born a long time ago, and they're all still correct. So let's say goodbye to Archimedes and water displacement and the king. Goodbye, everybody. Let's say that the king waves his hand at you. Goodbye. So I want to teach you something else. This is a nice, fun thing to do. What are the pirates going to do with all their money? You wonder, right? Well, here's a fun thing to do with your money if you had some coins. They had lots of gold coins. The Spanish gold, they called it. When the pirates went to the Caribbean, they got what they call the Spanish coins. So I want to teach you something very fun. When you put something flat on something flat, it doesn't rub, there's nothing sticky or rough underneath. It sits there with a little bit of what's called friction. Friction, just a little bit, actually allows you to stand up and not fall down on the ground. Because if there were no friction, no holding your feet just a little bit, you would be sliding all around. So we are really glad that we have friction under our feet. So when we step in a shoe, we don't go flat and fall on our bottom. Same thing with this beautiful coin. There's a quarter, and here's a penny, and here's a dime. Let's start with a penny, ready? So just a little bit of friction is good. If there were too much friction, it would stick to the card and it would fly like a flying carpet. But because there's just a little bit, it can move in a different direction. So what happens when something is not moving? Nothing. It doesn't want to do anything. It wants to stay just like it is, not moving. Even if I move the card from underneath it. Isn't that fun? So when there's something called inertia, can you say inertia? Inertia, good. When there's inertia, something is not going to want to move. When you sit down and watch TV or watch something, sometimes you feel your body saying, it's so cozy here, I don't want to move. That's kind of what inertia is. It likes where it is and it doesn't want to go anywhere. So I'm going to put this lovely penny on this card, and it's going to want to stay right where it is. But if I move the card, what will happen? It should go inside because the card will be gone. So inertia causes it to fall straight down and not go with the card. Let's see if I can do this. It doesn't work every time, but it's fun to try, right? Are you ready? Okay, say the magic word. Inertia. Ready? Here we go. One. I'm going to hit the card away and see if I can get that penny to go inside. 1, 2, 3. Here we go. Didn't work. Too bad. Let's try it again. Ready? I can do it as many times as I want because I can, right? Let's try it again. All right. Sometimes if you put more on the side, it's easier to do. So we're going to stick the card out more. That's what they told me in the instructions. Are you ready? Here we go. Say the magic word. Inertia. Ready? Here we go. Oh, it didn't work again. Should we try it again? Yes, because it's fun to try it again. I'm going to hit the card harder. Are you ready? Say the magic word. Inertia. Ready? Inertia. I did it! Yay! Okay. Should we try it? Do you see? Go in. Just to make sure. Let's put more money on it. Okay, we're going to put the card and a quarter and a dime and a penny. Oops. Let's put the quarter on and let's put the penny on because it's bigger than the dime. Ready? All right. It's a little trickier, but it's fun. We're getting good at this. We get to practice, right? All right. All these three things have a little bit of friction. They're touching each other. They're not too slippery. They're ready to go or stay. Stay. They're ready to stay instead of go. Are you ready? I'm ready to say the magic word. What's your word? Inertia. Okay, here we go. Count with me. 1, 2, 3. Oh, it didn't work. Should we try it again? Let's do it again. Kind of wondered. I never know. Sometimes you have to do it a lot of times. Okay, here we go. Let's put it right in the middle. There it is. All right, let's say the magic word and try it again. Are you ready? Here we go. Inertia. Here we go. 1, 2, 3. Almost. I got almost all of them. Try it one more time. Fun to keep trying. All right, here goes. All the pennies and the dime. All right, everybody. I want to hear you say it really loud. Inertia. Ready? Here we go. Let's try it. Take a breath. Oh! All right, one more time, just for fun, and then we're going to show you another experiment. Pirates don't have a lot of patience. I have much more patience than a pirate. So I would keep on going, but I want to do another experiment. So here we go. Ready? Inertia. We did it! Yay! How fun. You could do this all day if you want. All right. In fact, grown-ups, there's an experiment I will send you that has an egg in a paper toilet paper tube, and it is on a plate, and you can push the plate and the egg goes off the paper toilet tube and in the toilet paper tube and goes right in the water that you put in a jar. Isn't that fun? I actually did it on my first try. All right, so now I want to explain to you something about the pirates and the boat. So let's sing another verse of our pirate story. Are you ready? I want to see if you guys can help me understand how a boat floats. Are you ready? Okay, here comes our song. Do you see the boat on the ocean? Good. Okay, I'm going to sing you another verse. The west wind's force blew us off course the day I went to sea. I lived on board a pirate ship and the captain said to me, oh, we go this way, that way, port side, starboard, over the deep blue sea. This way, that way, port side, starboard, over the deep blue sea. And the pirates saying, there she blows. And this is a picture of a skull and bones, and it's called the Jolly Roger. That was a big, scary ship that the pirates in the Caribbean would see, and they were really careful because that was a dangerous pirate ship to go near. And I wanted to show you this beautiful picture. What do the waves look like? What did the artist give you the impression that the waves were made out of? Horses? Yeah, isn't that cool? Look at the poor boat, it's going like that. Rocking in the ocean. All right, so I want to show you something about the boats. Boats are made to float. Boats are made of different things. Sometimes they're made of metal, and sometimes they're made of wood, and sometimes they're made of both. So when I took this big dish of water, I had to figure out what is going to make a boat, which should be going down because the gravity in the earth, what pulls everything to the core, the middle of the earth, is called gravity, which it's always doing. It's pulling your feet. If you didn't have it, you would be floating in the air. And if you're floating in the air, you can't walk on the ground. You couldn't even float probably. So we say, what is pushing the boat up? Otherwise they would go down because gravity likes everything to go down. So we had to find out again, what is it? Well, we have to find out if something weighs more or less than the water. Now, if you take anything and you hold it in your hand and it feels a little bit heavy, do you think, put your scientist hat on, it's going to be heavier or lighter if you put it in the water? It's going to be lighter. It doesn't weigh as much. It doesn't feel like it weighs as much, and it doesn't weigh as much in the water. That's why it feels good to swim around in the water, right? So we're going to do another experiment like that. So when you put something in the water, if it's heavier than the water, what's going to happen? It's going to sink. If it's lighter than the water, it's going to float. And if it's equal to the water, it'll just stay close to the top. And that's called buoyancy. Now, why does it go up at all? Because water is strong. It has pretend muscles, and it has an up force. It pushes it up. So anything heavier, it can't push it up. But anything lighter, it can push it up, just like you can hold a beach ball and put it on the water. And if it's just the same, it's like this. You can kind of go up, but not too far. So we make boats these days out of something, in those old days, first out of wood, but then also out of steel. Steel or anything. Steel always, metal will always sink. It's always heavier than water. But if you mix it with wood, wood has something in it that steel does not. What do you think is inside wood? I don't see anything. It's invisible. Do you know what it is? It's air. Air is inside wood. That's what makes it float. Also, there's more of it if it's flat. So if the water has more surface, more area to push up, it can push it up more. So something that floats like this is not going to float as well, but something like this will. So if you make a little boat out of paper or something, you put it in the boat, water in the water, you can make it out of foil. It'll float better if it's longer. So you can make one of those at home, and I will show you how next time. But right now we're going to use this, and we're going to say, look how nice it floats. Can you see? Can you see how it floats? But now when they make boats, or a long time ago up till now, they mixed the metal and the wood, and the wood had air in it. So the metal and the wood together floated. So when you see the parts of the boat that are made to float, I will show you. It's called the hull. It has air in it. And here is a picture of the boat. Can you see? So this part has air in it as well as metal. So it keeps the bottom going up, and it's lighter than the water a little bit, enough so that it floats on top. And so it's a combination of metal and air and wood. And they're beautiful. Boats are beautiful. And they're all different shapes and colors and ways they make them. But if they have some wood in them, it will float. And if it were all metal, it would sink. So that is what's called buoyancy. What will float, what is buoyant, and what will not float. So bye to the wood, bye to the heavy plastic with some metal in it. This has a little, but it's still heavier than the water. And this is very heavy, and it goes right down, right away. I'm going to say bye to that. I wonder what will happen. Actually, let's ask a question. What do you think about this? Do you think this is going to float or not? A rubber band, let's see. It floated, mostly floating, right? It's kind of equal. So maybe it's the same weight as the water because it's not on top. So it's buoyant, but it's not on top. Very nice. Okay, now you cannot try this at home because it has to do with fire. Are you ready? Okay, it's our last experiment. I took a candle and I took a little bit of water. There's a little bit of water in here, if you can see it. And I made that so we can make a cloud inside the bottle. Now, I put a little bit of wax on the bottom, and I want to know how much it's going to take of oxygen to make a fire, because the pirates need a fire inside and they don't have electricity. So they had to use candles. But on the other hand, they didn't want their boat to burn, so they had to cover their candle. Now, if you cover it all the way and you don't let any more air in that is already, there's a little bit of air in here, then it's going to go out very quickly because there's not so much oxygen. Our little molecule, our Mickey Mouse molecule, has some oxygen in it. That part is in the air too. So we're going to take a jar and we're going to say, okay, there's some air in there. It fits. gonna go out if I leave it open like that. But if I blow some air and I put it like that, it'll trap what air it has. And it'll trap the water. When it gets hot, the water will go up because it bounces around. All the little electrons bounce around and they move faster and faster and faster. And they make the hot air go up and they warm the water and it turns into a cloud inside the pot. But before that, I want to show you how cool it is if you light the candle. The candle is going to light and make hot air very hot. And that heat is going to need to eat something. It eats basically to keep going. It has to eat the match, right? If I were having the heat on the match, it would burn the match down. In this case, it would burn the candle down. But in the air around it, it sucks up the oxygen and there's no more left. And then what do you think is going to happen? Is it going to keep burning if it has nothing more to drink or suck up? Nope, it's going to go out. All right, here we go. Here's the thing you cannot do by yourself. You have to do it with a grown-up. And I'm going to light the candle. And it may take a moment because they're special candles. Okay, you see that smoke? That is using up oxygen too. Okay, now we're going to take a little bit of air, put it in the bottle, and let's see how much oxygen is in there and how long the candle will last. Can you see? I'm going to move it up so you can see it. I'm going to use this side so you can see better. Oh no, it burned up all the oxygen so fast. It went out like that. And then what happens is hard to see, so I'm going to move it up. It got a little foggy on the top. That's like a cloud on the inside. So it warmed up the water and it warmed up the air and it used up all the oxygen. Give me an O for oxygen. Oh, very quickly. So that is the story of a pirate's booty, a pirate's light, and a pirate's life for me, and a pirate's bathtub. When a pirate jumps in, the water goes up, and a pirate boat that floats. And we're gonna sing a song about the pirate ship getting to where it's going. You ready? Here we go. We sang the song the whole day long, the day I went to sea. Oh, the pirate's life is full of fun, the pirate's life for me. Look how much fun they're having. Oh, we go this way, that way, port side, starboard, over the deep blue sea. Oh, we go this way, that way, port side, starboard, the pirate's life for me. Aye, mateys. Thank you for joining me. I had a wonderful time with you. Thank you, everybody, and we're going to say goodbye. Are you ready? All right, we're going to sing our steam song that we are learning. Are you ready? We love everybody because they're different, because we know nobody is the same. Together we can make a difference, because together's the way we win the game. Full steam ahead, full steam ahead, full steam ahead, full steam ahead. Thank you, everybody. Have a great day. Bye now.